Good afternoon, this is Alex. I'm working for let me jump to the second page. I'm working for MiTAC. MiTAC is a Taiwan company. We design and manufacture servers. Today, thank you for the chance. Let me introduce our concept about the edge server use case, especially for the 5G RAN. Firstly, I want to share you my journey for the edge server. The first edge server we designed was for the telcos in China. They were using this server for video streaming at the edge, probably the central office. Then 1 year after, we developed OpenEdge under OCP OpenEdge project together with AT&T and Nokia. And the server in China, besides the traditional computing version, there are also storage version and the GPU enhanced version. On the other hand, in 2020, we joined ORAN. So together with OCP and the ORAN, we know there is a use case to use the OpenEdge for the ORAN, especially for the DU server. Then after we know the special use case, which is ORAN DU, we purpose-built a 1U DU server in 2020. So in the the early few years, we define or we know some hard requirement for the edge server. For example, the need to be front access, short depths. In the beginning, we try to make the server under 500 millimeter, but now we know it's even better under 400. And you can guess the power at edge should be constrained, so we try to design the server with lower power consumption. Also, maybe need to handle higher temperature. We designed operating temperature up to 55. So that's the few key factor at the edge. So in this story, I already point out two use cases. One is for ORAN DU. The other is for MEC, edge computing server. Let's talk about the use case for the ORAN DU first. So while we do the Open RAN, probably we have the same open concept like we do for the data center. Like we separate the hardware and the software. We define the interface. For example, the open interface for the RU, DU, and CU, actually, it defines all the way to the core network. And if you do ORAN DU, we are talking about the physical server at the radio side or cell side. You still need to add more time sync function. So that's why we have the time sync section later. And you need FEC to handle the data processing between the RU and DU, which means you need to process the huge data from radio to the DU itself. And since DU is in between radio and the CU, so you need a NIC for the front haul and mid haul. In this case, we try to configure that by an OpenEdge server. It's a one-socket server, so while you select the CPU, you better choose higher core count so you can handle, you can have better performance for virtualization. And there are two expansion slots on this server, so I can use one of them for the FEC and the other for the NIC, of course, with time sync function. So OpenEdge actually is a long life product. It's still available on the marketplace. Besides that, it also migrates from generation to generation, adapt the newest CPU. That's the OpenEdge. Like I mentioned, since we know there is a specific DU use case, so we purpose-built the server like this. We are working on contribute the spec to the OCP, try to get the OCP-inspired logo. We still design it as a one-socket server. And if you zoom in this photo, or you have chance to go to MiTAC booths later, you can find there are SFP connectors and also some SMA connector, which means the 1 PBS and 10 megahertz time sync connector on the board. That means we design a NIC circuit on the board. Besides that, we also offer 2 expansion slots, which means you have flexibility to add or change accelerator car or NIC car, many or. So that means the flexibility. And like I mentioned, there is a NIC on board. So totally we offer 200G bandwidth. Then the second use case is for MEC. I think the concept probably is like to move the computing, the storage, the NIC from cloud to the edge, but make the server smaller. And the other concept is we try to do the AI and the machine learning on the cloud, but to do inference or recommendation at the edge. So if we try to configure this feature to a specific server, still use the open edge, we can do this way. Again, it's a one-socket server, but we have different use for these 2 slots. One is to use the GPU car, and the other still use NIC car. But in this case, we have more chance to use OCP 3.0 because you can see if the OCP 3.0 is being adopted, there is additional space for the storage. A typical use case is to use E1.S. So OCP 3.0 adopt a few space. Also, E1.S also adopt a few space. So we can put all of them on the front. So again, this OpenEdge server is available on the marketplace. Besides these things I mentioned, purpose-built. So like I mentioned, if I go back to the original slide, the right-hand one, the purpose-built for here we name it Firestone 2. It's another choice. To have GPU enhanced version, you can add more GPU function for the edge computing. So that's the 2 introduced for the 2 use case. Then action, we try to present the 1U DU to the project team in Q2, and hopefully we can get the OCP Inspire in Q3. Then we keep join the project, both telco project and the edge project, to understand and identify more use case. Hopefully I can have the use case 3, so I can come back here next year. All right, that's it.
Thank you, Alex. Any questions from the audience?
Yes, please.
Thank you for the presentation. I had a question. I apologize if I'm a little bit ignorant, but I was reading that one of the challenges with deploying disaggregated servers for ODU functionality is just the sheer workload they need to handle in ORAN.
That's right.
And that means plugging in accelerators, like you said in the expansion slot, then making the solution very expensive. Is this something that's holding back the deployment of ORAN, in your opinion?
Actually, in our deployment, we found many different kind of scenario from different telcos. So since I mentioned we are a server company, we try to position the requirement which need a physical server at the edge side. So we call it a kind of green field, which means there is no radio tower cell site in the field before. For example, there is no 4G signal. So in this case, while we want to set up a 5G and also adopt by Open RAN, we found the opportunity to use this kind of server. in that kind of field, they can spend the money to get the 5G signal. That's one of my experience while I discuss with telco. But again, you are right. If it's for brownfield, actually, it's a kind of, it's different. You need different kind of thinking. You need to compare with legacy equipment like Nokia and Ericsson. Yeah, that's totally different. Yes?
My question is also related to ORAN deployment. So in terms of redundancy at the green or at the brown field, do you deploy a single edge of those boxes or multiple?
Most of case is a single box. Yeah,
Okay.
and also again, it match my first explanation is in greenfield. You don't need to service lots of users, but you need to service it a very difficult environment. A typical example is actually our first POC is in India. Yeah, so maybe that answer why we can adopt this kind of server by ORAN in a greenfield.
Okay, thank you.
Yep.
When you look at your ORAN server,
Yep.
Has MiTAC given any consideration to doing AC versions of that versus the DC versions that we're showing, to make it a more general purpose server to use it in other potential markets?
Okay, I got a totally different feedback from different country. For example, I just mentioned India. They say most of the cell tower they want to set up is DC. But I heard from the other country, they say they also need AC. So you're right, while we migrate to next generation, we try to design in power supply solution. If we do the DU server more like what we do for the data center, I can change the AC, DC power supply easily. Yeah, so yes, we are considering that.
Okay, thank you.
You're welcome.
All right, thank you, Alex.
Thank you.